Today we're going to review how to simplify radicals, and we're going to start off by taking the square root of perfect squares. So here we have a list. I don't know if you recognize 1, 4, 9, 16, 25, etc. as perfect squares, but they are because when you take their square root, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3 because 3 times 3 is 9, 4 times 4 is 16, so there's that square root. So we can fill out this entire table. So you understand that perfect squares, when you take their square root, they result in an integer value. So we have to be good at recognizing our perfect squares. These are from 1 to 12, the perfect squares, or the square roots of perfect squares from 1 to 12. And then we're also going to look at what it's like to have a variable that's a perfect square. So when you have an even exponent, any even exponent is considered a perfect square with a variable. And what you do is you divide the exponent by 2. So you divide the exponent in half when you take the square root. So we can write that down here. And try some of these. The square root of x squared is just going to be x to the first. The square root of x to the fourth is x squared. The square root of x to the sixth is x cubed, and x to the eighth is x to the fourth. So any even exponent we can take the complete square root of. So here's what we're going to do. We're going to simplify the following. Now if you look at this guy, we always look first. 64 is a perfect square, and x squared, because it has an even exponent, is also a perfect square. So we can completely undo this thing, and it becomes 8x. 2500, the square root of 2500 is 50, and the square root of x to 1000 is going to be x to the 500. You divide it in half. And then for c, when we have a fraction, we can take the square root of the top and the bottom. So the square root of 4 is 2, and the square root of x to the fourth is x squared. So that's the process for taking the square root of perfect squares, whether they are integers, fractions, or variables with even exponents. Next we're going to review how to reduce a radical to simplest terms. And this happens when we don't have a perfect square, when there's a number that isn't a perfect square under the radical. So first of all, we want to do just review a little bit of terminology here. If I have some kind of radical number, irrational number, the number inside the square root symbol is called the radicand. So that's what this 7 represents. And then of course the number that's outside is still going to be the coefficient. So those are the two terms that I'm going to refer to. The coefficient is the number on the outside, the radicand is the number on the inside. So here's the process. This is what we do. We take any non-perfect square that we want to take the square root of, and we're going to split it up into two parts. We want the largest perfect square that divides evenly, that is a factor of your radicand, and we're going to put that in the front square root symbol. And then the remaining factor is going to be in the second square root symbol. And then what you do is you're going to take the square root of the perfect square. So you're left with something like a coefficient in front of a radicand. So let's take a look at a couple of examples here. Radical 32 is our first example. It's not a perfect square, so I'm going to immediately write down two radical signs. And now I got to think, what is the largest factor of 32 that is a perfect square? And think about your perfect squares. 4 is a factor, but it's not the largest. The largest is 16. And we know that 16 times 2 is 32. So when you think of factors, you think of what number can divide into that. Not the largest perfect square that's less than 32, but it has to be a factor of 32. And then what we do, we're going to take the square root of the perfect square and leave the radical as it is. So my final answer is 4 radical 2. Now even though 4 is a perfect square, he's not under the radical sign anymore, so he just stays 4 radical 2. So let's do this again. The next one is radical 500, so I'm going to put down my two radical signs. The largest perfect square that goes into 500 is going to be 100. Again, you can use the list from the first page, and 5 is the other factor. We take the square root of the perfect part, and we end up with 10 radical 5. The next one has a variable. Now here's the tricky part. This variable has an exponent of 3, so he's not perfect. We have to split him up. 16 is a perfect square, so our first step is to put down the two radical signs. Since 16 is completely perfect, the entire 16 is going to go under the first radical symbol. And then we have to split up the x cubed. Well, if I divide x cubed by x, I'm going to get x squared. So whenever you have an odd exponent, all you need to do is pull one variable out of it, and that's going to create an x squared and an x. You're never going to have an exponent greater than 1 with the variable in the non-perfect part, because once you take one out, you have a perfect square. So now we take the square root of this guy. The square root of 16 is 4, the square root of x squared is x, and I end up with 4x times radical x. Now that answer looks really weird, but you just have to get used to that. You're going to have these goofy answers with variables and variables under radicals, but it is correct. Alright, for the next one, again, I'm going to separate this out. We have a perfect part and a non-perfect part. If you look at this, 3600 is actually a perfect square because it's 60 times 60, so I'm going to put the entire 3600 under the perfect part. Now x to the fifth we're going to split up like we just did before. I'm going to put a single x in the non-perfect part, which is going to turn x to the fifth over here into x to the fourth. So if I put one x over here, that's all I need. X to the fourth is now perfect because any even exponent is a perfect square. So I take the square root of 3600 times x to the fourth. So it's 3600, the square root of that is 60. If I take the square root of x to the fourth, I get x squared. And then my radical x just stays the same because I can't reduce him anymore. Now you also have to be careful with some numbers. Some numbers where you know some of the factors, you're really used to specific factors, but they aren't perfect squares. Because when you think of 48, you might think the factors have to be 6 and 8. But neither 6 or 8 are perfect squares. So there are other factors of 48 that are perfect. When we split this up, the largest perfect square that goes into 48 is actually 16. And that's 16 times 3. So I've got the 16 in the front, the perfect part. The 3 is going to be the remaining radicand when I'm done. And now I split up the x cubed. How are we going to split up the x cubed? You're going to toss one x in the second radical, leaving you with an x squared in the front. So again, look, I always only have a single exponent, or a single variable in the non-perfect part. Because once you remove one of them, your exponent is even and therefore perfect again. Taking the square root of the front, I get 4x, and then the remaining radical stays unchanged. It's 4x, radical 3x is my final answer. Okay, the next one, we just repeat this process. 125, the largest perfect square that goes into 125 has got to be 25. Because there aren't a lot of other perfect squares that end in a 5. 25 times 5 is 125. So you take the square root of the perfect part, and you end up with 5 radical 5. The next three, the next two I'm going to leave for you to try on your own. In your notes, before you get to class, do those two. And then let me talk about the last one. 16 radical 16. What happens when we've been practicing these things is that you forget to look for perfect squares from the start. 16 is already a perfect square. So instead of doing, here's the coefficient that's going to stay with it. Instead of doing this and breaking it up, some kids will say 4 and 4. That's not going to help you. Don't do that. It's not going to help you because 16 is already perfect. So this coefficient is going to stay out here as 16, and I take the square root of this part, which is 4, thus leaving you with 64. So that's when you have a perfect square as a radical, you're going to have a whole number as an answer. Now what I didn't touch on was the fact that when you have a coefficient in front, he's going to stay in front, and he's just going to get multiplied by your answer. So you are going to finish this off and then put a final answer there. The same thing with h. You try G and h, and then we will practice more of this in class.